So hello everyone, today in this video we are gonna solve a problem of the day of the GFG, that is a equalize all prefix sums. So let's now read the problem statement. Given a sorted array and for each index I means between from 0 to n minus 1, make all element of the array from index 0 to I equal using the minimum number of operations. Now in one operation we can either increase or decrease the element of the array by 1, and we need to return an array that contains the minimum number of operations for each I to accomplish the above task. So now I'll explain you this with an example. So here I have taken the first example. So basically what we will do, we will create a sub array starting from the 0 index. So here 1, then 1 6 1 6 9 and 1 6 9 12. That's what they have said in the question. We have to consider all the arrays from index 0 to I, and we need to make them equal. So over here you can see that in the first, if we take this first particular case, means from 0 to 0 index, how many operation we need to make, how many number of operation we need to make in order to make all elements equal. So here we can see that there is a single means there is only one element, and one element is equal to itself. So we don't need to do any subtraction or addition. So here it is 0. Now we will see second. So here 1 and 6. So elements are not equal, right? So we need to make them equal. So now what we will do? So here we will select any one element. So here I am selecting 1 as my middle element, and I will make all other element equal to 1. So here what I'll do, I'll make this 6 equal to 1. So if I make the 6 equal to 1, then what is the number of operation do I need to perform? So I'll perform 5 number of operations. So that is why my answer is 5. You can also select your middle element as a 6, right? So now here in the third case, again middle element is 6, and I will always means always middle element is always mid of the array, right? Because if you select the middle element, then only you will get the minimum distance. You can also try using the pen and paper, and you will observe that selecting the middle element will always result into minimum distance. So that is why we will always choose middle element. So similarly, if you do this, you will get answer 8, and here also if you do this, your answer get 14. So this is your final array, and that's we want to do. So now means we will here understand that how can we do this efficiently, and what they have said in the question, we need to solve it in a O(1), means constant space, right, excluding the resultant array that we obviously need to make. So what we will do over here is, so you will take the second example, right? So in the second example, we are finding out the answer for 0 to 6. We are basically trying to find out the answer from 0 to 6, right? Initially forget about the all other cases like 0 to 0, 0 to 1, 0 to 2. No, I am directly finding the answer for 0 to 6. So if you want to find, so what you will do? Firstly, we will pick the middle element. So what is my middle element? My middle element is 7. Okay, that is performed. Now you need to make all element equal to 7, right? So what you will do? So understand. Now see, who is the previous of 7? Previous of 7 is all these ones, right? And who is the next to the 7? So right means to the right of 7. So right of the 7 is these, right? So what I need to do, I need to make them equal to 7. So I'll do step by step. I'll go step by step. What I'll do the sum of array of 0 to 2. So what is the sum of these elements? Is 3, right? And what I need to make them, means what I want them to be. I want them to be each element equal to 7. So what I'll do, I'll multiply 7 3 times. That would be 21, right? And I'll minus them with the 3. Why? Then only I will get the number of operation that I need to perform in order to make all element equals to 7 to the left of this particular 7. Am I right? So that's what I have done here. See, I am explaining only the one part, so you will understand it. So see, 7 into 3, that is nothing but a 21, and I'll subtract it from with the sum of these previous numbers, right? So that is nothing but you will get answer 21 minus 3 is nothing but 18. So it means 18 numbers of time you will perform the operation, means you will do addition in each number in order to like make them equal to 7. Similarly, what you will do now, we will consider this means to the right of this 7. So to the right of 7, numbers are greater. So you won't be like doing this same thing. Rather, you will subtract the sum of these 3 with the 7 into 3. Now see, here 7 into 3 means what you will do, you will like this 3 is nothing but a number of element to the left of 7. Right? And here this 3 means the number of element to the right of 7. So number of element to the right of 7 is 3. That is why I have written here 3. And I'll do the sum of these elements. So what is the sum of these elements? Sum is 36. So I'll subtract 36 with these 7 into 3, because again here also I want to make them equal to 7. So that is why 36 minus means this, and you will be having your answer as a 33. So you can also see that over here the answer is 33, right? So basically if you have observed, then we are doing nothing but here we want the prefix sum. Here if you have observed carefully, means what we are doing over here, we just need the prefix sum, right? So now how we will solve this question? So I'll just let me just show you my code. So along with the code, I'll explain you how can we like, so you can solve this question, right? So okay, here is my code. So here what I have done, here I have find the prefix sum. Why? Because you will be needing the prefix sum. See, 0 to 2, 4 to 6, this is nothing but a prefix sum, right? You can see. Now what you will do, we will iterate our array, means we'll process the element from right to left, not from left to right. I'll also explain you. So let me just explain over right now only. See, if you will process your like answer array, means your array from right to left, then only all the prefix sum would exist here, right? Because in this question, means in the solution, we will be like putting, means replacing the answer, actual answer in the prefix sum itself. We will not be using any extra array, right? So that is why when you are sitting here at 6, right? So at 6, what is your answer, means what value exists over this 6 index? So actually the prefix sum from 0 to 6 is the value present at this index, and we will be overwriting this value, right? Overwriting this value by what? By this. So when you are like standing at 6, all you need is previous index, the value of previous index. You have no relation with the values present after the 6, means to the right of 6. There is no. You have also seen that when you are like sitting at 4, you are only needing these previous values. You are not needing the 5 and 6. That is why, again, what I'll do, I'll start from right and I'll move to the left. I hope it is clear to you, right? Otherwise, if you like, you can start from left to right. Then if you do this, you have to like maintain a separate array, that is a prefix sum, right? Then you can do. But since like we want to solve it in a like constant time, so that is why like I am processing it from right to left. So I'm here, right? So what I'll do, I'll find the middle element first of all, middle index, and I'll see if this particular middle index is like greater than 0. This is like to such that this particular middle -1 is not like exceeding my bound, array is bound. It does not get out of bound, right? So that is why if it is like 0, so I'll set it to 0, means there is no previous to middle. Then what I'll be doing, then I'm doing this particular stuff, right? This stuff is nothing but I have explained over here only. So where it is, okay, here only. So what I'll be doing, I am at a middle, so I need the answer prefix sum of these values. See, 0 to 2. So here middle was 3. So I need the prefix sum of middle -1, right? And that's what I have done here. I need the prefix sum of middle -1. So I have stored in this value. Otherwise, if this middle is like 0, so I'll be automatically like setting its value to the 0. So I need a middle sum and I have taken it. So now what I'll do, this is array of 0 to 2, right? So over here, we are like first considering this case. So what we will do, here you just look over here, right? Just forget about this particular part. I'll explain you later. So first of all, array of mid is 7. Array of mid is my 7, and 7 into what is like mid. So 7 into mid means 3, because number of element to the left of 7 is nothing but a position of the 7, means index of this middle element. So that is nothing but a 3. So 7 into 3. I hope you understood, right? And minus value. Value is what? The sum of these previous elements. That is nothing but a prefix sum. So I hope like this is clear to you, right? Now we will understand this. This is nothing but the answer for the right side. Answer for the number of operation for the right elements. So to the right of 7, what is the sum of these elements? So what is the sum? So sum is nothing but a prefix of I, means currently where I am, minus value. Value is this. Value is the prefix sum of these elements, because I want to have the sum of all these elements, right? Then only I will like make them equal to 7. So once I like know the sum of these elements, see here I have like considered the 7 inside my answer, means in the to the right part, but you can also ignore it, right? It is up to you. Means during the coding I have like considered it, so you can also skip it, right? This particular 7, actually it would get cancelled only at the end. So that's why I have what I have done. I have like I have the prefix sum till this index, and that I have subtracted the prefix sum till here, right? So this is nothing but my that only. And then after what I am doing, once I have the answer, then I will subtract it by array of mid into number of elements. So what is the number of elements? See, array of mid by 7, and 7 my I'll 7 multiplication 1, 2, 3 and 4. So that's what I have done here. See, 36, that was my already answer there, and 7 into 3. So these are the numbers of element. So that's how like you can solve this problem. And finally I'll return my answer. So now I'll just compile the code and see. Yes, it is working fine. Now I'll just submit it. So yes, it indeed got accepted. So I hope like this problem is clear to you. If we talk about the time complexity, so time complexity of this problem is big O of n. And if we talk about the space complexity, so space complexity is constant if we do not consider this array vector. So I hope it is clear to you. If still you are having any doubt, feel free to ask me in the comment below. And if you are like new to my channel, I would encourage you to subscribe it, like this video if you enjoy, and share with your friends. Thank you.